Hello and welcome back to the show. My name's Relevant. This is Do All the Things. On today's episode, a 3-channel Mesa dual rectifier solo head. We're going to be talking about tube rolling, what tubes do what, and then we're going to be doing a bias mod on it. So stay tuned. Ooh. A frickin' millipede just fell out of this amp bud. Whoever had this amp before my buddy just bought it, it was a little filthy. Probably kept it in a grungy basement or something. You can kind of see because there's like little spots of corrosion in places you wouldn't normally get corrosion. Either way, seen here is a representation of how many tubes you actually need to make this amp work. It has a little bit of a tube surplus, if you will. This tube here is your overdrive, your booster / clean channel tube. Half of it's going to be on the clean channel, but the main half of it is going to be your booster. It takes the signal from your guitar and boosts it to drive the rest of the preamp. It's the overdrive tube. The signal that comes out of it is mostly going to be clean, but loud. These tubes here are what actually will be generating your distortion texture. If you're trying to fine tune your distortion texture, you know, fizz, grain, mid, you focus on these two tubes. This guy right here, that's your effects loop buffer recovery tube. As you can see, you can omit it completely in certain configurations. Specifically, if we look at the back of the amp, we have this knob here that sets what the effects loop does. If you put it to loop bypass, it removes the loop altogether, and then that tube's not used. Now, generally, you're gonna need that tube under most circumstances to get the most out of this amp, but we've actually omitted that tube for now because it's broken and also for demonstration purposes. However, if you do omit that tube and disable the loop, you notice on these two knobs here, output and solo, it says loop active. These things get completely disabled. So if you want a global master or your solo function, you need to be using the loop, you need to have that tube in place. However, each channel has an individual master volume that you can use to blend the volume levels you want. You might ultimately get, if you don't use your effects loop ever, a more transparent tone doing it that way. I have come to believe over the years that there's not a lot of benefit to having a tube buffered effects loop. There could be under circumstances where you are implementing your amp in such a way that you go for the cranked amp tone restart to distort your phase inverter and your power section. But generally the Mesa isn't designed to be that kind of amp. It's the kind of amp that generates its tone in the preamp, and then the power section just makes it loud. Also, when you're tube rolling your amp, each tube that's in there colors your tone. If you can use this amp in a way that omits this tube, you have one less tube to color your tone, one less tube to roll. Finally, this last tube is your phase inverter. Now, if each one of these preamp tubes is the same make and model of tube, you aren't even close to scratching the surface on how good your amp can sound. The tubes that sound good generating distortion are not the same tubes that sound good buffering, these guys. And then this one will be different too. So as a random example, in an amp of this nature, in the first position, I would have something like an ECC83S. It's a good high gain tube to drive the rest. These, I might have JJ ECC803S's. They're one of my favorite distortion generators. Maybe the Mullid 4004, the Electro Harmonics 12AX7s. The Svetlana 12AX7s, JJE83CCs. Those are among my favorite distortion generation tubes. And then here, you're gonna have clean buffer tubes that sound good transparent. Tungsol 12AX7 is a good option, but I find this amp is a bit bright and harsh. To smooth it out, a Sovtek 5751 in the phase inverter. The Tungsol, I might use that one for the effects loop buffer, or also a Sovtek 5751. The Sovtek 5751, just in general, is a good buffer tube. Over here, those are the rectifier tube positions. You don't need them. Well, you do need them if you use them, but if you're not using them, you don't need them. One of the claims to fame with this amp is it's a dual rectifier. You can switch between tube rectification or silicon solid state you know what I mean. If you only ever use silicone mode, you're not using these tubes. They're just producing heat, using electricity for no reason. To top it all off, how much you want to bet there's all sorts of users out there of this amp who will retube their amp, they'll change these tubes, but they never actually use these tubes. There's people out there checking out perfectly good rectifier tubes that they've never used. And then meanwhile, here in the power section, I only have 2 tubes. That's right. You don't need 4 tubes in a 100-watt amp. You do if you want 100 watts. If you regularly jam or play at stage volume volumes and need all the headroom you can get because you want that clean, tight preamp distortion tone, then yes, 4 tubes is good. But if you're like me, you're a home gamer noodler, like, I never need that volume. And to top it all off, what you don't do with a tube amp is change the tubes when they get worn out. Well, you do, but that's not the only reason why you change the tubes. You want different flavors. You want to buy tubes like your girlfriend buys shoes. Oh, this is in season. Oh, I feel different flavor, different color today. I'm gonna, I got some money. Maybe I'd like to try some of those Tungsol 6L6 GCs. That sounds like a good idea. I want to try a different flavor in my amp. So, if you're trying to save money and you want to get a taste of what different tubes have to offer for cheaper, why buy 4 when you can buy 2? Why buy 4 when you can buy 2 sets of 2 different tubes? Now, in a preamp gain topology amp like this, that's your booster. You will feel this tube more than you hear it, though some models will drive more mid or less mid downline, which will affect how these tubes generate distortion. These will generate your distortion texture, the characteristics, how much crunch, fuzz, but obviously they will have some effect on your EQing. These 2 tubes here will function as EQs. They will less affect your distortion texture and more affect, how much mid, how much high, how much bass gets through the circuit. Much of the same way when you're doing the preamp topology, that's what your power tube's gonna do. And I'll guarantee you, different power tubes sound different. And you might switch out these stock 6L6s and put, say, EL34s in there and be like, oh, wow, that sounds real good. However, the only caveat is we cannot do anything with these tubes, changing these tubes out, unless we can bias them. And of course, Mesa wants you to buy their tubes. I guess they have that kind of sorted out. These appear to be Sovtech 5881s. Not that they're bad tubes. I don't find that any tube is intrinsically bad. Is that the correct word? It's just they're different flavors, and sometimes you prefer different flavors. So that means we need to bias mod on this thing. So how does this amp bias? Well, it's fixed bias. There's no adjustment in it like other amplifiers. And in fact, there's no real test points either. If we look at the circuit where the tubes are mounted down there, the power tubes, well, we have our 1K screen grid resistors, but I don't see any 1 ohm current sense resistors. I guess grounds are going to be in here somewhere, unless I can find some other ground connection, because that's essentially how you do it. You have to intercept ground going to a power tube and see how much current it's drawing. But no, I see nothing of that sort here, sir. At the end of the day, I might not bother trying to do a mod to this. I would just go ahead and purchase the tool that you need. If you're paying this much for an amp, I'm assuming you can afford some support tooling for it, like this guy here. This will intercept the ground connection to your tube and allow you to measure the current. That's how we're gonna work on this. However, you still need to be able to adjust them on that bias. So, how's that done in this amp? Well, seen here is the power supply schematic, and down here and over in the corner is the bias supply. So we got our 60 volts AC here, gets reverse rectified through this 007, little 825, little bit of drop in there. Then we have our first capacitor, which this schematic's wrong. Wow. Plus is going to be on this side. That's a typo. Interesting. Sometimes I swear they put little Easter eggs into schematics so that people who don't understand how amps work can't read them properly, or it would sabotage their efforts. That's a thing that exists. Now we have some form of 3.3K dropping in the other cap, which should also be the other way around. And then boom, these 2 ground resistors and a 3rd ground resistor. So basically how it works is the greater the negative voltage you give the tube, the colder it's gonna run. You decrease that negative voltage by reducing these resistor values. The lower these values are, the more voltage gets grounded out, the lower this voltage is gonna be, the hotter the tube's gonna run. So, negative 39 volts to control some EL34s. That's great. What happens if that's running too hot and we need to turn it down? Well, seeing as how this bias select switch is involved, we have to raise either the value of this resistor or this resistor so it bleeds off less negative voltage. That's the long and short of it. So looking at this schematic, if we want to do an adjustment mod to it, I say leave this 82K in place because it is going to have the least effect, right? And then replace this 22K with a pot, and then that will allow us to adjust our 6L6. Typically we use 50K potentiometers. That's going to be able to give us the ability to go all the way down to frig all voltage, but also increase that value all the way up to 50K, which should give us a lot more than 52 volts negative voltage. Meanwhile, over here, we also replace that with a potentiometer, and now we can change the value of the EL34 setting. The only thing you have to remember is the EL34 setting just adds resistance. So it will not work independently of this resistor. We need to set an initial value with this resistor first, and then we can switch an augmented value here. So we can bias this amp to quickly switch between two different tubes. They don't necessarily need to be EL34s. You could have two different flavors of 6L6s you want, or you could do something like have a bias setting for 2 tubes and a bias setting for 4 tubes if you just want to noodle at home, but then, you know, get more power for outside the house. Just what's going to happen is your first setting here is going to be for whatever colder set you have, and then this setting would be for whatever hotter set you have. So where are these in the amp? It's funny because they don't have any component labels, and it took me a little bit of looking over to find them. They're all over here. Seeing here is the lead that goes out to the bias switch. Actually, it's these gray ones right here. And that connects right here to a 15K. So that's our 15K switched one. That's the one that we want to replace with a potentiometer. And it looks like we can get it off the board without having to get under the board. If we just moisten up this solder with some fresh solder, the pads are big enough that we can get heat to the joint. Can't really grip on it though. There it goes. Yeah. All right, that's out. Now let's see if we can suck on these holes. Yeah, they don't have component number labels on here, but they will tell you the value. Bear in mind, your Mesa model may vary. So where is Monsieur 22K? We're gonna leave the 82. I do recall it being right here. These capacitors here are the bias supply. There is our first 4007. Then here's the 825 ohm. There's the 3.3K. And then over here, bam, that's our bias. And that little link jump goes to there. That's the part of the phase inverter distribution that distributes the bias to the power tubes. So it's this 22K right here. All right, let's see if we can hook onto this pupper and get her out. I think we might need to pry on that one. Gently pry, gently pry. There, just like that. Now that it's up, I should be able to do a straight up, boop, and it's out. I'll just suck on them holes, bud. So that's pretty much where we're going to be inserting those potentiometers. Now I need to make a determination real quick how I want these potentiometers to go. They're going to go generally in this general area. That seems to be one of the few places that has room. Now if we do righty hotty, because like it's backwards, right? The hotter we want it, the less impedance. So if that's maximum hot, the wiper is going to be pointing here, and that's going to be max resistance. We turn it down, it will get colder. So we're gonna link these ones together. That's a thing that exists. To top it all off, we need to determine which terminals on this guy are ground. All right, so the capacitor on this position is going to be the ground of that circuit. So of this, we know it's not gonna be that one, so it's probably gonna be this one. Oh yeah, look at that. How about up here? Which one's ground? Looks like it's gonna be this one. Oh, no, okay, ground's at the other side of the switch. Oh. Let us now prep on our potentiometers. So we're linking two together. That's gonna be, I guess, the main wire. It doesn't really matter. So I do believe traditionally, even though it doesn't really matter, the wiper is put on ground and we hook it through one of the ends too. The idea here is if your wiper fails, you do not lose load. You know, if your wiper fails in your bias pod, it's just gonna pump up that voltage real high and your amp will go cold. So it's not the worst thing to happen. We'll make this black and blue one the main pot. We'll make green and white the second pot. 2 pots, 4 wires still on the spools, not to be cut till we determine exactly where they're gonna go. Now we know, we want them around the back, and generally this free space here is where they're gonna go, which puts it right about here. But that means they're gonna be sitting underneath this board. We need to get this board out of the way so we can drill holes and mount the pot. Let's see if that can be done, sir. The hope is that we don't have to wicked, like, rip everything out here. We can just lift this well enough. Okay. They're also attached to tube sockets. These don't have spacers underneath. They're just like metal screws screwing into the metal. They're also the tube socket mounts. That's an interesting way of doing things. Uh-huh. Maybe if we tuck these wires down, we can kind of shift this over. Oh, this white wire is going to be tightness. Might have to start disconnecting wires, so take us some photos, sirs. Disconnect these main power lines here. How much movement do we have now? A little bit more, a little bit more. This screw on this side has to come completely out. Okay, we can finagle this board out and up. And how much slack do we have? Not a lot, but it should be enough now. There's lots of room underneath there. So if we roughly determine where we want these to go, clearing there, like there and there should be enough clearance under all these components for it. Maybe put them a little closer together like that. Maybe we use that screw hole as a pilot for one. Yeah, if we do that, there's lots of room. All right, shredder's coming to get you. Oh, this isn't as soft steel as some other chassis. Now have the correct size hole. Put one of those there. Deader one, go about there, about the middle of this sticker. We have some reasonable index points because if we go the center of that mount hole, center of this hole, we can kind of determine our alignment this way, just roughly the middle of that sticker. Our next hole is going to be right there. Calling the consultant. Consultant say what? Yeah, that's what it says. I missed. Don't forget to jump around the bar, jump around the bar. You cannot impress her if you don't jump around the bar. This is annoying. It's like right there, but I can't get any tools in at the correct angle. This has become more challenging than I anticipated. I know what might work. It'll make a bit of a mess, and it'll be a bit surgical. Basically, we don't have clean holes, and they're just, you know, messy on the inside here. Ideally, you need to drill a cleaner hole. I forgot about that for a moment. And those cone bits don't generate the cleanest hole. You need certain speed and consistency, and like, you know, a drill press does it real well, but it's not pretty, but it works. Now those holes are better looking. Yeah, almost. Still a little bit, eh? Still a little bit. Of course, it sprays flakes everywhere. That's great. All right, let's see if we just clean up debris out of there. Get this thing finally put together, bud. Yeah. All right, with its guts half hanging out, let's see if we can't put this pupper back together. So we kind of want to do stuff with the same orientation as the switch. So the EL34 switch will be on this side. Might do a little twist 'em on them. So we're gonna kind of get the wiring down and under here. All right, let's tighten her. Now the other one, I'm gonna install a posing face. I might start giving it a bit of a twist too. Gotta get it fished all underneath these wires so they don't get in each other's way. This one's actually gonna be facing the other way because where the wire's going. All right, let's tighten that one up now. Oh, if we turn them all the way this way, they should be on their coldest setting, right? Unless I messed up again. I always think I have the orientation of bias pots sorted, and then when I actually go to use them, it's backwards. At least they should be consistent pot to pot. So now we gotta try and get all these wires back into place. Or this board, I should say. Huh? Uh-oh. Does this board actually sit lower than the pots? Uh-oh. Did I really just make that epic of a mistake? I think I did. 12.7 millimeter. We have a 1/2 inch clearance. Well, it should just clear those pots. Just. There's something wedging between here. Oh, there's a diode. The Rectifier diode. Oh, really? We are not being undone by a diode, bud. Yeah, that diode is touching the pot. Okay, so note to self. If you do this pot, move her over just a little bit more. Just a little bit more. Maybe stick the other one here. You know, if we remove those rectifiers altogether and go only tube rectifier. No. Okay, so I made a mistake. Yeah, I have to move that pot over. It's the smart thing to do. I measured the distance of the board to the chassis. I confirmed that there was enough room for the pot to clear. But this diode, I didn't notice the diodes were at the other side of the board. And now I have a situation where the board doesn't fit over the pot. So I've never done this before to this amp. This is a first. That's kind of what I do sometimes. I figure out how to do certain modifications to amplifiers. And every now and then, mistakes are made. But we do it for your benefit, don't we? So, certain aspects of butchery. We're gonna have an extra hole in this guy. Oh boy. So that whole position is no good. But if we move over this way, we should have room over here. They're about 3 centimeters apart. 2.9. All right, time to drill another hole, but gonna use a real bit here to try to take a more cleaner approach so it's less annoying to deburr when you feel it just start to grab that last little bit. you take the pressure off. Except we still need to use the cone bit to get it up to size. Again, we'll just use more speed and less pressure. There we are. All right, how are we doing for internal hole cleanliness? Oh, way better. Not the best, but way better. Actually, you know what? We have just enough clearance here. I might be able to get the cone bit in and clean it up that way. Yeah, if I do it like this. If I lightly grab onto the very end. A wonderful thing about drilling holes, when you have to deburr them and chamfer them, the worst of the chowder is always at an angle in which you cannot get the tool. Those are the rules of reality, don't you know? All right, potentiometer install take 2 now, sir. Now, one thing I'm gonna do before I put this back together, after having re-evaluated my clearance, is I am going to do a little bit of surface prep, and I'm gonna be covering this part of the board that's over that pot with some nice insulation so that, you know, none of these high voltage points can actually accidentally touch it. It'll stick better to here than it will to the pot. And this isn't normal electrical tape. This is thick rubberized electrical tape. All right, now let's see if we can't put this guy back together. Ah, yes, now it fits well. And it's tight, like the board with that insulation is touching the pot. There is just like maybe a millimeter of clearance. So like my tolerances were tight to begin with. My tolerances always tend to be too tight sometimes. All right, kind of back to where we started here. Now we just have to connect on all these various potentiometer lines, which we want this to come up and around. Ideally, we probably want to bundle it up with some of these guys here. All right, well, let's loosen this off. Have that wire come up and around and go roughly like that, which means our cut's gonna be right about here. Just have to feed this wire up and over. Give them a little strip. Don't need much. Twist and a bit of tin. Now we're gonna do with the white wire towards the switch. Now, if we poke it mostly in the hole, you can't really see. Just a little bit of the tinning exposed, we should be able to flow some solder right in there. Yeah, no problem. Ta-di-da. Put our replacement zip tie in place. Now for the other bias line, comes out from underneath there, comes up here, and it's got to go all the way over here and down there. This would be nice if it had more zip ties left. Cutting right about here should be good. A little bit more of a twist. Seem to have cut them in uneven lengths. It's okay, it's a feature, not a flaw. Same procedure. Tin them up, flow some solder on there. There we are, done. Here, I'll get you a different angle so you can see on it better. Tacked in, tacked in. We should be able to bias on this now. Before we do, I'm gonna drag this to the tool shed out back and blow it out with some compressed air, make sure all the debris is free. I'll be right back. All right, I think it's adequately decruded now. Let's throw some tubes in this bud. And for power tubes, well, we have to start with the 6L6 types. So for 6L6 types, I'm using Tungsol 7581As, which I do recall sounding pretty good in this amp last time I tried them. Coincidentally, tube store value at 20 to 23 seemed to work well in this amp with its stock bias settings. Now we need to get our tool in place though. Because we're using 2 tubes, we plug our 8 ohm cab into the 4 ohm output. You'd plug a 16 ohm cab into the 8 ohm output. And if you have a 4 ohm cab, well, I guess you're a little SOL, though I've never really met many only 4 ohm guitar cabs. Usually they're switchable between 4 and 16. You see, the only thing that really differentiates between 2 and 4 tubes is the impedance of the output transformer. It might be something like 4K for a 2-tube amp, but 2K for a 4-tube amp. Now, mind you, that impedance is always proportional to the cab impedance load. By doubling the impedance load on the transformer itself, it will consequently double the impedance load on the tubes. So we're testing current in milliamps. Now it should be good to plug in and fire up. Now what you have to remember, these switches are proportional to the switch. So that's the 6L6 and that's the EL34. That's going up pretty fast. So it seems these particular tubes are starting at 12 milliamps. And that's what the pot turned all the way down to cold. Now if I switch over to EL34, it's gonna bleed off more current. That number should go up. Yeah, it does, roughly half. So what you have to remember is the EL34 selector is the sum of both of these pots. However, the 6L6 selection is only affected by this one. So if you change your 6L6 bias, you're gonna have to readjust your EL34 bias. Now the fancy thing is, we should be able to test voltages on what, pin 3? Apparently this amp's about 480 volts. 30 watt spec tubes. That's a max bias of 62. 62 times 0.5 is 31. That's our minimum target. 62 times 0.7 is 43. So we want 31 to 43 on the bias of these tubes. Now, because of the nature of this amp, they tend to bias it colder. All right, that should be biased for the 6L6s now. Let's test on this thing. I understand why people use overdrives with them. All right, so what have we determined? The bias mod works, and these tubes are hot. Now let us pull these tubes out and get some, how about some 6CA7s, some JJ6CA7s. One of my favorite tubes for high gain amplifiers. High gain, just those bitey amps, just, they add some warmth. Now the EL series of tubes in which the 6CA7s fall, they need less negative voltage. So in the 6L6 settings, they should run rather cold. Yeah, look at that, we got like 1 milliamp so far. Now remember, one tube's gonna be a little bit hotter than the other. So ideally you wanna flip-flop back and forth to figure out which one's gonna be a little bit hotter. Let's do that now while they're still cold. That's 2.4. Like, you'll start to see a proportional difference even before they fully warmed up. This one's 2.8, right? So let's switch over to the EL34 setting. That's gonna cause the bias to go up. And then we fine tune about the same numbers. They're 25 watt tubes, the bias is gonna be a little bit different. So instead of say 35, we might opt for 30, 32, somewhere in there. But if 70% was like 42 on the other tubes, then 35 should still be within range. Now obviously you wanna get the tubes good and hot before you final bias them. Fine tweak them after a bit. Oh, hey, 333, close enough. Get a bit carried away here. This bias is up to 36 now that the tubes are good and hot. Bring them down just a touch there. Here, let's actually do some math. Target's 52 max, 26 to 36. So actually we gotta come down quite a bit for these guys. There, 31.5. So, if we flick it back to 6L6 mode, you're gonna notice that bias dumps out. And I should like fine tune bias this thing actually, because those 6L6s probably weren't that hot. 7581As are a type of 6L6, just like 6CA7s are a type of EL34. But with it in 6L6 mode, these tubes should sit back to about where we set them. Yep, 32. There we are. And you're gonna notice, just like I said, look how many tubes are missing from this amp and it works just fine. And we're done. The only thing left to do now is put this pupper back together. Ta-da! It's a classic, it's a classic. Not my favorite sound in the world, but I wouldn't mind owning one just for the collector value. But they still demand quite the fair price, so I don't know. We'll see. Maybe one day. In the meantime, I fix them for other people. And truth be told, I don't get very many of these through my shop. I guess they don't really break down much. So maybe that's saying a good thing. Well, I hope you enjoyed this. If you did, stay tuned for more. I work on amps sometimes, or sometimes I work on computers, or sometimes I work on, I don't know, man. Stay tuned and find out. Mesa. It works.